So what we're fixing to begin is what's called systems of equations. So what's an equation?
It's
Math statement with an equal sign. Just math symbols with an equal sign in it. And if I'm going to have a system of equations, all that means is I'm going to have more than one math statement with an equal sign. When we're graphing lines, two-dimensional lines, then we're going to have to need two equations to solve the system of equations. So if you think about what's happening here, I've got two lines, right? They're both in slope-intercept form. There are three possibilities that can happen when I graph two lines. Can you guys tell me what they are? Think about what could happen if I graph two lines on the same plane.
Either they intersect or don't.
Okay, so they could intersect. I agree with that. That's one option. They could be parallel. That's another option. One more option. What does that mean? That's it. So when I graph two lines, these are the three possibilities. So when I solve the system of equations, these are the three possibilities that could happen. So anyways, when I'm solving system of equations, there are three possibilities that could happen. They could intersect at a point. When this happens, the solution is the point that they cross. So the point that they cross, the x and y ordered pair, that is the solution. Okay, what about the second case? What if they were parallel? Where do those lines cross? They don't. So this is the case where we would say there is no solution. And the third case where we have the same line that's graphed on top of itself. How many solutions would it have? You'll use both words that I wanted. The answer we use here, this is called infinitely many solutions. It's pretty good. You had both answers on there. Now, a lot of people get confused about infinitely many versus all real numbers, or they think everything's a solution. Infinitely many does not mean that everything's an answer, because what are the answers? The points where they cross. So that means, if you think about it, this is an answer, and this point's an answer, and this point, and this point, and this point, and this point, and this point. And how many points could I draw on this line? I could draw infinitely many points. But if I drew a point here, is that a solution? No. So it's not all solutions. It's not everywhere is the answer. There's just so many I can't list them all. Everybody see the difference between all real numbers versus infinitely many solutions? Y'all don't care. Okay, cool. We're going to first do this. The whole lesson today is all going to be graphically. We're going to learn there are other ways that we can solve systems of equations that don't involve graphs. But for today, we're going to graph everything to figure out what it's going to be. So if you think about it, what's required for... So there are three possibilities. One solution, the lines cross. No solution, the lines are parallel. Infinitely many solutions, I'm graphing the same line. If I look here, are these both in slope-intercept form? I should know which case it is right now. Is this going to have one solution, no solution, or infinitely many solutions? How do you know?
Because opposite reciprocal.
So they are opposite reciprocal slopes. So these lines are actually going to be perpendicular. That's one case. The whole goal is you should look at the slope and be able to identify what's going to happen. What has to happen to have no solutions? The lines must be parallel.
They have the exact
Same
same slope.
slope. What's required if they're the same line?
Same one.
They'd have the same slope again, but everything will be the same, right? So it's neither one of those because these have different slopes. If they have different slopes, they're going to cross somewhere. This case, they were perpendicular, but that doesn't have to be the case. As long as they're different, they're going to cross. So let's graph these lines to find their solution. I think this is the one I ended up thinking was, yeah, that was the best one of the ones I had. So let's graph them. So this is a review. If you don't remember how to graph lines, right now is a good time to pay attention. Right? I mean, we just got done doing it, but hopefully it never fails when we do this lesson. People are like, I don't know how to graph that. Where were you at when we went over that? And we also had that discussion about how you guys don't use the Math Excel properly, right? We're going to do better this time. Ask questions on the Math Excel day. Don't wait till test day. Easy Bridge, Math Excel, they're all the same. Yeah, they're all the same terminology. Anyways, let's graph this one first. How would I graph y equals negative 2x minus 4? We use the y-intercept first. The y-intercept is negative 4. So I go down to negative 4 on the y-axis. I plot a point. Then what? We use the slope, which is negative 2 over 1. That tells me I should go down to right 1. I can do this as many times as I want to. I could also go up 2 and left 1. That's on the same line. There's me graphing the first equation. Any questions there? The second one I'm going to fix. I don't like the way it looks. So 0.5x is a decimal. I can write that as a fraction. What is 0.5 as a fraction? Is everybody okay with that? Now it looks like a rise over run. I like that better than I like a decimal. So how would I graph this line? Y-intercept, which is 6. 1, 2, 3, 4, 5, 6. Plot the point. Then we'll use the slope. Up 1, right 2. Up 1, right 2. Up 1, right 2. Up 1, right 2. We also go down 1 and left 2. Down 1 and left 2, down 1, left 2, down 1, left 2, down 1, left 2. So this one has one solution. What is that one solution? It's that ordered pair where they intersect. It is at negative 1, negative 2, negative 3. It is at negative 4. And if I go up, 1, 2, 3, very good. So the solution to the system of equations is negative 4, 4. So talk to me about solving this system of equations. What are some benefits and what are some negatives or some cons of graphing the two lines?
It would take longer.
So that would be a con. It could take a little bit more time to graph two lines.
A pro is if you don't know, if you can't tell what kind of line it is.
It's very visual, right? You can really see there's the solution. When we start doing the stuff that's algebra or algebraic manipulation, moving the equations around, it's not as cut and dry. You can't see the solution as easily. But here I graph it. I see that's where the lines meet. That's my answer. Right? I mean, it's very visual. Another con. If you're like me, I'm not great at drawing straight lines, and I'm not good at being very precise. If you're a little off, you're going to get the wrong solution. Right? If your lines aren't exactly correct, you'll have them crossing somewhere. Like, even if they cross, like, just here, just a little off. Well, that's a wrong answer. Okay? So here is one way you can check your answers. Is there any questions so far? This is all you have to do, is this. A way you can check is you can plug in this x and y. It should make both equations true. So think about if I plug this in to the top equation. Okay, so let's do that very quickly. Instead of saying y, I'm going to say 4 equals negative 2 times. Instead of saying x, I'm going to say negative 4 minus 4. Does everyone understand? I've plugged in the x and y to the top equation. It follows that? And then simplify this. So on the right side, what is negative 2 times negative 4? 8. And then what is 8 minus 4? So you see how it says 4 equals 4? This makes both equations true at the same time. Now if I plug it in, it should also work for the bottom one. It has to work for both to be the solution. So if I plug in negative 4 here, that's going to be 4 equals 0.5 times negative 4 plus 6. What is half of negative 4? Negative 2. What's negative 2 plus 6? Different signs. Different signs. We subtract the numbers. Keep the sign of the dominant number. 6 is dominant over 2. Keep the positive. So this says 4 equals 4 here. You see how it made both equations true at the same time? That means it's the solution to the system of equations. This is just a way you can check. All right? You can always check that way. So when you guys start asking me questions on test day or test review day, I'm going to ask you, have you checked your answer? Did you plug it in? You're like, I don't know how to do that. You never showed us that. You're a terrible teacher. Wait, is that what? That's how it goes, I think.